Welcome to a new section of this video course, SELinux policies. Until now, we've been working with an existing SELinux policy by tuning our system to deal with the proper SELinux contexts and assigning the right labels to files, directories, and even network ports. In this section, we'll learn to manipulate conditional SELinux policy rules through Booleans and to create new custom SELinux policy modules. We'll then move on to develop user and application domains. Then we'll see how to replace existing policies with new, custom ones. We'll end this section with a few examples of custom policies that augment our SELinux experience, and fine-tune the policy to match the security requirements that the administrator has in mind. Now we move on to the first video of this section that deals with SELinux Booleans. In this video we'll learn to list SELinux Booleans, and to change Boolean values. Then we'll inspect the impact of a Boolean. One of the methods of manipulating SELinux policies is by toggling SELinux Booleans. We use the secure mode policy load Boolean. With their simple on and off state, they enable or disable parts of the SELinux policy. Policy administrators use SELinux Booleans to manage parts of the policy that are not always needed, but still have a common use case. So here we have the AWS instance with RHEL 7.3. I've already logged into it. My root is EC2 user. Now let's first look into listing SELinux Booleans. An overview of SELinux Booleans can be obtained using the SEmanage command with the Boolean option. On a regular system, we can easily find over 100 SELinux Booleans, so it's necessary to filter out the description of the Boolean we need. So let's use the SEmanage command. Type at your terminal SEmanage Boolean -L, the pipe symbol, and grep policy load, and click enter. Here the Boolean is to determine whether the system permits loading policy, setting enforcing mode, and changing Boolean values. Set this to true and you have to reboot to set it back. The output not only gives us a brief description of the Boolean, but also the current value. Actually, it gives us the value that's pending a policy change and the current value. But this will almost always be the same. Now let's see another method for getting the current value of a Boolean, which is the get SEBool application. So here's the command. Get SEBool _secure mode _policy. You need to execute. Let's click enter. So you can see that the secure mode policy mode is off. If the name of the Boolean is not exactly known, we can ask for an overview of all Booleans and their values, and filter out the one we need. Let's execute the command for this. You can see that it returns the same output. Now, execute the command get SEBool -A, which will return the available Boolean on your system. Another utility that can be used to view SELinux Boolean descriptions using the SEPolicy Booleans command. Type at the command line SEPolicy Booleans -B secure mode policy load and press enter. Here we got the output with the description. This command, however, does not show the current value of the Boolean. Finally, Booleans are also represented through the sys/fs/SELinux file system. Let's run this command. Here, Booleans can be read as if they were regular files, and they return the value 0 for off and 1 for on. Now, we can change the value of a Boolean using the set SEBool command. For instance, to toggle the SELinux Boolean, we can use httpd_can_send mail, which enables or disables the policy rules that allow web servers to send emails. Let's execute and check this command. SELinux Booleans have a default state defined by the policy administrator. Changing the value using set SEBool updates the current access controls, but this doesn't persist across reboots. In order to keep the changes permanently, add the -P option to set SEBool. Let's add it and execute the command. In the background, the updated SELinux Boolean value is included in the policy store. The current policy file is rebuilt and loaded. As a result, the policy file, called policy.29 for instance, inside etc SELinux targeted policy is regenerated. Another way to change and persist a Boolean setting is to use the SELinux Boolean command, which we're about to use now. In this case, the Boolean value is modified, that is -m to on. Persisting the changes will take a while as the SELinux policy is being rebuilt. Non-persistent changes are almost instantaneous. The larger the SELinux policy on a system, the more time it takes. Now let's see how to inspect the impact of a Boolean. To find out what policy rules a Boolean manipulates, the description usually suffices, but sometimes we might want to know which SELinux rules change when a Boolean is toggled. With the SE search application, we can query the SELinux policy, displaying the rules that are affected by a Boolean. To show this information in detail, we use the -b option. For the Boolean, -a option to show allow rules, and -c option to show conditional rules. Let's press enter and execute this command. So you can see all the details which I just mentioned. In the example, we can see that the rules are prefixed with 2 characters, that is dt. These inform us about the state of the Boolean in the policy, which is the first character, and when the SELinux rule is enabled, second character. Now, with SE Tools version 4, the -c option is no longer available in the SE search command. When a Boolean is selected using the -b option, only those rules affected by the Boolean are shown. The output is also slightly different, showing only the active state of the rule, that is true or false, rather than the 2-character state that's displayed in the previous example. The state reflects whether the SELinux policy rule is currently enabled or disabled, and whether the rule becomes active when the Boolean is on or true, or off or false. So dt means that the rule is currently not active, but will become active if the Boolean is toggled to the on state. When we query the SELinux policy, it makes sense to always add the conditional option so that we can easily see whether the policy supports a certain access based on one or more Booleans. Let's consider the web server domain, that is httpd_t, which has many policy rules governed through SELinux Booleans. We might want to see which rules are applicable between the web server domain, that is httpd_t, and user content type, which is userhome_t. So to check this, you need to execute this command. Let's do it. So, we've found 9 semantic AV rules. Wonderful! In this video, we dived into SELinux Booleans. In the next video, we'll explore about enhancing SELinux policies.